Good morning, everybody. At least it's morning here in Oslo, where I'm sitting. I guess we have people joining from different parts of the world, but good day to you in that case. So this is the webinar about how RIIM is a very good and optimal solution for industrial and building automation. We are, as normally, we're waiting 1 or 2 minutes after 10 o'clock to make sure that everybody has joined. There is a tendency that some are joining 1 or 2 minutes past, and then we will get started. This webinar is a webinar I have been looking forward to talking to you for a long time. I was hoping to do this also a lot of 2021, but it never fitted the schedule. So I'm really excited to talk to you about this today, because it really shows it's not only about the technologies, but how the technology can be used to give improved value to systems out there, real systems in the real world. And that is very exciting for me. So I think I will get started. So my name is Ørjan Nottveit. I'm the R&D Director at Radiocrafts. This webinar is scheduled for 30 minutes. And then we have a 10 to 15 minutes Q&A afterwards. You can present yourself in the chat if you want to, but it's not mandatory. And of course, you can post the Q&A questions during the sessions, but we will try to read through them at the end of this in the last 10 to 15 minutes. So we will not answer questions during the 30-minute presentation. So what I'm going to talk about today, I'm going to talk about industrial and automation, and also building automation with wireless extensions. What are the challenges? What are the possibilities? I will talk about how old systems can be retrofitted with wireless, see how the typical modern PLC integration with wireless is done today, and what added value you get from using an IP-based wireless mesh solution together with your automation systems. So that's the agenda. So first I'm going to talk why am I talking about this? Because why are we considering industrial automation and wireless systems? Well, first of all, wireless systems is not something new for automation systems. It's been there for many years. It's been a bit slow in progressing, because it's a very traditional industry which likes to use wires. But wireless obviously has its advantages, because it reduces the cost, eliminating wires and the wiring itself, and thereby increasing the insight you have into your plant or your factory or your building's state. Also, there has been a huge growth of IoT technologies over the last 10 to 15 years. I mean, with improvements in sensors, in energy harvesting for having battery operated or even IoT devices or sensors without batteries. In the wireless technology itself, it's been huge improvements. And also, now we see the impact of machine learning and edge computing into these systems as well. That means you don't want to take all your data from your factory and put it into the PLC. Maybe there is some sort of edge computer in between, edge device in between, doing the machine learning, trying to understand, learn what these sensor values means for the building. Do we have to increase ventilation or reduce ventilation, depending on stuff like that. So there has been a huge development there. So what is a automation system? And of course, for most of you, this is well known, but I just want to make sure that I have everybody on board here. So automation system consists typically of some PLCs, maybe some RTUs, remote terminal units, which are controlling something in your factory or in your industry or in your building. Maybe you also have a SCADA system on top, which gather data from many and have some nice dashboards and stuff like that for operating environment. Maybe you also have a cloud connection so that you can check the status on your mobile phone wherever you are in the world. And also the PLCs will then control something. Either it's a stepper motor, some relays, or whatever. It will control something, and it will detect something, which is sensors. So it could be a position of a device, or it could be, I don't know, temperature of something, or the pressure, or whatever. So you have some sort of sensors, and have some actuators. This is the traditional like automation systems. And just check. I was also intending to have this one on, so you can actually see me. Okay. So how does this PLCs and RTUs communicate with these devices? Well, there are kind of 4 typical ways they do this from the historical ways, which are IOs. So it could be digital IOs or analog IOs. Then in the 70s, I guess the field buses have their was starting to use on typically RS-485 or 2-wire systems. And of course, the modern systems are a lot based on Ethernet or IP-based systems for this communication. But of course, still analogs and digital IOs are still used if you want to control a relay or something like that. What you see here is that there is no inherent wireless technology in this, which brings us over to the okay, we can take the interfaces first here in a different setting. Digital IOs, typically 0 to 5 volts or open close type of relay controlled. Analog IOs are analog voltages, 0 to 5 volt or 4 to 20 milliamp current outputs. Field bus in use are, of course, Modbus, RTU, Profibus, KNX, which are all serial buses based technology. And of course, lately you have Ethernet and IP based, where you have all these old buses trying to get on top of IP, like Modbus TCP, Profinet, KNX IP, backnet IP. But you also have technologies like MQTT, which pop up as a new technology, which seems to be very much liked by all different PLC vendors. So that's kind of a new technology coming into this market. So then the challenge we're trying to solve today, and that is when you have your PLC, you have your interfaces, but then you want to extend this to devices which might be a long distance away. You don't want to have the wires. You want it to be a reliable communication because you don't really want to get your sensor data. Sometimes you want to get it basically every time. You can have battery operated devices. Of course, then you don't have to draw the power cable to these positions either. And you both want to have sensing and control. It means you both want to have data from the sensors to the decision making in the PLC, and you also want to control things. And the control can also be battery operated in case there is some you want to set some indication different places in the factory, for instance, which can be based on battery operated devices. So this is the challenge, and the question is, how do we do this when the PLCs doesn't inherently have this technology? There are some PLCs which try to integrate wireless technology, but then probably it's like, okay, we have included Wi-Fi. Okay, great. Wi-Fi is great for application which creates a lot of bandwidth. It can do both control and sensing, but it cannot do long range, and it can typically not do battery operated devices. So you could have technologies integrated into PLC, but typically it doesn't necessarily fit the application you're trying to solve at the moment. So how to do this? We could use the analog I/O and use a retrofitting on that, meaning that we have a wireless adapter which reads some sensors and put out analog voltage depending on, for instance, if you read the temperature, you can put out a voltage depending on what you read. So this is a kind of straightforward way to integrate wireless solutions into PLC, but it's very limited. I have an example here of a system from Phoenix Sensors, which are a BLE hub, which reads some BLE sensors and put out analog voltage. It's possible, but to use the analog I/O or the digital I/O for that part of the PLC is very limited, because it's not a very function-rich interface. It's a very limited interface. So I don't think that would be used a lot, but if all you have on your PLC is some available analog I/Os, you could do it this way. Then you have that you can retrofit using the old field buses. That's typically done by having the field bus connection to like an IoT type of gateway. And then you have two options here. Either if you want to talk to a Modbus device, for instance, in this case, I'm talking about Modbus, then you might want this original Modbus packet coming from the PLC to go transparent through the IoT gateway, through the wireless adapter, and directly into the Modbus RTU. So that means maybe you want a transparent system if you want to talk to existing devices. But you can also make new sensors with the wireless technology, which does not have the old Modbus RTU interface. These are more directly wireless sensors. In that case, you need to do some sort of mapping inside the IoT gateway to take your data and transfer it to Modbus. So in that case, the IoT gateway has to emulate that it is a Modbus slave. So it kind of replies to the master as it is a Modbus slave, but it kind of gathers the data from a wireless systems behind it. Then I talked about MQTT. I'm not sure if everybody knows MQTT, so I added one slide about it. It's kind of it's a model protocol based on IP. It's publish subscribe type of protocol. So there is a broker in the system. The broker then handles the sensor data that you want, or the commands you want to send, and you can subscribe to that. So that means there could be sensors which publish their reading to the broker, and the broker then have noted that, hey, this PLC has subscribed to this value. So every time it's updated, I will push that data down to the PLC. And MQTT is, I see, very popular among all the PLC vendors. If it's Mitsubishi or Siemens or Rockwell or Emerson, or any of these, they all support MQTT now in their PLCs, because they all have Ethernet support, and the MQTT then becomes a software package that they all support. So it seems that this is becoming a very much standard for how PLCs want to integrate to wireless systems. So how does it then look when you have want to use MQTT? Of course, if you go from the left here, we see a PLC. To have the MQTT software there, that is supported by all the major vendors. So that's very easy. It works straight out of the box. Then you need some sort of IoT gateway which have an MQTT broker inside, which there's a lot of examples for. It could be like a Raspberry Pi, it could be an industrial PC. There are dedicated IoT gateways like the Semantic IoT 2050, which comes with an MQTT broker default when you buy it from the store, Converse gateway and stuff like that. So there's probably hundreds of these different gateways available. So that means whatever wireless technology you're using, that can be then, the sensor will send the data through whatever wireless technology you're using, and you will put this into the MQTT broker. I will show you an example afterwards on how we solve this. In addition to MQTT, there are other like IP-based or TCP or Ethernet-based technologies as well, which the PLC or the RTUs like, and they could all pretty easily be integrated into any IoT gateway. So it's either, if it's a Modbus TCP slave, that's also very easy. For instance, if you use Node-RED, which is a very easy to use application development system for the gateway, this can be handled in, it's like 1 hour development to have a Modbus TCP slave running on this IoT gateway. So that works pretty much out of the box. So it becomes the same system as with MQTT, meaning that you get the data in from any wireless systems, and you just transfer them to the Modbus TCP slave, and then whenever the master is asking, the TCP slave will, of course, reply based on the data it has. And then basically you can do the same with other technologies. Profinet is the same. So again, I'm not going to repeat everything I said about Modbus TCP, but it works pretty much the same way with other technologies like Profinet. However, I do think that MQTT seems to be the leading way to do this. That has to do with Profinet is very much for like very low latency systems. And here you have wireless sensors. So obviously, we're not talking about 10 microsecond latency or even 1 millisecond latency in these systems. The latency is more in a wireless system. So in the most high-end system where your latency requirement is very in a few milliseconds, you might want to use Profinet, but it doesn't really make sense to have wireless data going through a Profinet, because wireless will never have the same accuracy and timing as Profinet can. So how does a RIIM fit into all this, and what do we have to offer in terms of added value there? That is, of course, a very good question. This is not a presentation about RIIM, so if you want to know more about RIIM, you can go onto our webpage. You will find, or our YouTube channel, you will find probably 10 different webinars on RIIM and the different aspect of it. So this is one summary slide, which I will do just to make, in case some of you are a bit new to RIIM. RIIM stands for Radiocrafts Industrial IP Mesh. So it's a sub-1 GHz mesh. By doing sub-1 GHz, we get very good range. So that means we have 4 to 8 times range, for instance, compared to what we'll have with a BLE link. So obviously it's gives very good coverage. It's based on open standards, so it's very future-proof in terms of it's based on IEEE 802.15.4 G and E, and RPL, which is a routing mechanisms defined by the IETF. It's of course auto-forming and auto-healing. It's based on IP, so that 6LoWPAN. So that means you typically do UDP, co-op, and DTLS as the protocols used on top of it. It uses time-slotted channel hopping, or TISH as we call it, which is stolen from Wireless Heart and the ES100, which has been the state-of-the-art industrial wireless solutions. But that has been taken from the 2.4 GHz where Wireless Heart operate and put down to 7 GHz. And the application that the user will run inside the module. So that means every user can customize the application inside. by standard C code to write the application which run inside to define the behavior of his node. So that was very short. Again, there is a lot more information about RIIM on our webpage. So if you want to dig into that, please do. So how do we do like tailor RIIM to fit this market? Well, first of all, we can look at the lower interface, lower layers. Of course, we have support for RS-485 so that we can be used for retrofitting field buses. We have, of course, a line driver for TX-RX, which means you can just plug a line driver for RS-485 directly to the module. I actually have that on my desk here right now, so it's been running. Also, we have added the drivers for doing Modbus RTU packets. So that means we handle the addressing and the CRC in these drivers, and we offer them both for the master and slave. And through these drivers and the physical properties, you can communicate directly with the RS-485 driver to a Modbus device. And these examples that I'm not talking about, the drivers and the example how to use them are put on our GitHub page. So you can download them there with documentation, picture, wiring diagrams, and everything which we use to have this up and running. So what we get by this example is this solution, meaning that we can do Modbus, transparent Modbus. So that means that you can send data from your PLC through our RS-485 driver to the module, and the data will come transparent out on the other side, so you can connect to a Modbus RTU slave, which is the example, one of the examples which are on GitHub. You can, of course, also do other, maybe that comes to the next slide. Yes, what we also have the ability to do is to take actuator or sensors which are not interfacing a Modbus slave, but they are just, I don't know, any sensors, CO2 sensor or a vibration sensor, any sensors which is directly integrated with the module, can send data as a using the standard IP protocols like over UDP and CoAP and secured with DTLS. So using the state-of-the-art IP technology to the gateway, and the gateway can then emulate a field bus device. So it can pretend it's a Modbus RTU slave and reply to the commands, and of course the firmware to set up the IoT gateway as a Modbus slave is also easily available online. In this case, the interface between the IoT gateway and the module is through something called serial line IP. So this is basically IP packets going over UART. And by doing this interface, we have a true IP connection, IPv6 connections to each sensor. So that's not that important for the PLC here, because the PLC doesn't relate to IP, but the IoT gateway then can very easily be integrated to any cloud service on or something like that, which is based on IP. So it makes the whole integration much, much smoother to use IP. So how do we support MQTT? It basically uses the same method as I showed in the last slide. We have actuators and sensors. We, of course, when we do the example code, we use our sensor board, which is part of the development kit for RIIM, which have some built-in sensors. So those are then sent to the IoT gateway. In our examples, we have used a Raspberry Pi, but as I said, you can use You can use Raspberry Pi, or you can use more industrial rugged gateways as well. We integrated with SLIP to the IoT gateway, serial line IP. And we have shown how we very easily, with very little effort, have running Node-RED on this Raspberry Pi, and how we transfer the incoming co-op resources to the MQTT broker. So we push the data to the local MQTT broker. So this is like, again, the effort level is like much less than 1 day to have this up and running. And we are then able to have an MQTT broker on the Raspberry Pi, which can be used by a PLC or any other device which needs this sensor data. This example has also been put on our GitHub page, so you can look at it there. I think it's called something with MQTT. I don't remember the name exactly now, but it is available on our GitHub page. So I think this is the most future-oriented way to do integration of RIIM together with automation systems like PLC. While the other one, which was based on Modbus TCP, is more suited for retrofitting old systems when you have existing PLCs out there which doesn't necessarily have Ethernet and MQTT support. So those are the two ways that we see are most relevant for our customers. But as I said, you can easily integrate to Modbus TCP or Profinet or anything else as well. Reliability, yes. I mentioned that reliability is one of the key factors when you integrate wireless systems into this with automation systems. And traditionally, it's been a lot of skepticism in the industry because, wireless, you will lose some packets. And yes, you will lose some packets. So, of course, it depends on what type of packet loss you can accept. If you can accept 99.9% packet reception, that might be okay or not okay for your system. Typically, for the very high-end systems, like ES100 and wireless HART has been used. One of the main reasons for that is their time-slotted, this is time-slotted channel hopping and not time-synchronized. Time-slotted channel hopping, and which means that each device gets assigned a time slot so that it can send more and not be disturbed by other nodes. And this feature has been taken from wireless HART and ES100 and copied to RIIM. So we are basically using the same time-slotted channel hopping as these industrial standards are using. But we are doing it on 7 GHz, so that means that every hop has a lot bigger range than you have with these 2.4 GHz systems. Also, when you do downlink, meaning that you want to send commands from the central unit, IoT gateway or the PLC, and have battery-operated devices, that's a very big challenge for normal wireless systems, because all the sensors need to pull the gateway and say, hey, is there any information for me? Is there any information for me? And if you have hundreds of these sensors in a network and you want everybody is asking every 2 seconds, is there any data for me? The system will basically be jammed. So that's also one of the advantages with the RIIM, is that when we have TISH, all the nodes are synchronized, so we are able to send data down, and even battery-operated devices then only wakes up at dedicated time slots, which makes it possible to operate on battery or even energy harvesting. So what have I been talking about today? I want to do a bit summary here. PLC and automation systems does not inherently have wireless solution, at least not the correct wireless solution that you need. There's multiple ways to integrate wireless into automation system like PLC. Typically for retrofitting old systems, old PLCs, you might want to look into a field bus extension. like we showed for, and we have shown for Modbus, at least on our GitHub page. And we see that MQTT seems to be a winning technology for modern systems. Also, when you look at the wireless systems, you want good range, you want reliable communications, you want downlink traffic and battery up to the devices. And considering those 4 requirements, I do really believe that RIIM is an excellent fit for these type of applications. We have put a lot of software examples and firmware examples on our GitHub page, so that has a lot of information for you now, so that you can go there to check out what help you can get there. It is really low effort to do this type of integration now. And you can, of course, get our hardware development kit at DigiKey if you want to get started yourself and working with this. So that means we have concluded my presentation in just about 30 minutes, as I promised, and I'll see if there are see on your question here. Let's just see here. Is there any configuration GUI for RIIM? No, there's no configuration GUI because for RIIM we do have a SDK, a software development kit. So that means you program or you set up the module how it will behave with a small C program. It's typically 100 lines of codes for the easy applications. So that means there is you have a lot more freedom with RIIM because you can program the device and not just configure it. But you can basically set like the same things in the program, like how you want TISH to be set up, or what channels to use and output power and all these kind of things. You can basically configure in when you write the software. Together with SDK, there are like 10 or 15 examples already, in addition to the examples we put out on GitHub. So there is plenty of examples how to set up RIIM. What type of wireless topology is possible necessary with RIIM? Well, wireless topology, I'm not quite sure what you mean by that, but we do have it's by nature a mesh technology. So of course you can also use it as a star in smaller networks. So you can have if everybody is in connection with the central unit, which we call the border router, it will obviously be a star network. You can send between devices, but it's typically made to take data from a central unit or down to the different devices to one, or maybe you want to send to all, like in a multicast, which we support, or data going up from the sensors up to the system, up to the central unit. Then we have a question about a webinar covering TISH specifically. It's a good question. I'm not sure if we have like a TISH only webinar, but there's I think there's specifically if you look on the reliability webinar, which I believe we had, I think it will cover a lot of TISH thing. But I think you can just look on our YouTube channels or on the webpage, and you will have an overview of all the videos. But I don't think we had the one which had like TISH specific in its heading. Then we have a question: what technologies do you consider competition to RIIM? Well, there's a lot of different technologies, and I guess they all pretty much have their advantages and disadvantages. As I said, we have customers looking into Wi-Fi. Obviously, it's a completely different radio technology. But if you want to like transfer video from a position to a central gateway, obviously we cannot do videos over RIIM because RIIM is a pretty low data rate system. But BLE is very much used for short range. Then you have other technologies, as I mentioned, wireless HART is 100, which is very like high end and stuff like that. What about OPC UA? Well, that's kind of on a different level than I would say in RIIM, so it's not. I don't really consider that a wireless technology as such. I'm not sure what you mean with the questions, David, about the OPC UA. ROM and RAM available for the user code. I believe it's 32K of flash and 4K of RAM. But we have looked into some customers want 64K of flash, and we might be able to do that. As a mesh, I guess I could have self-healing Modbus R2 network with multiple leaves. Yes. That means you can have several, you can talk to several devices. So what we do in the Modbus RTU example is that when we look at this from the example code that we have on GitHub takes the Modbus packets coming from a PLC. We look at the address. The first time it's an unknown address, so we send it to all our wireless nodes, and then obviously one of them answer because it's the right Modbus address, and then we note the IP address of that device. So we build up a table in the central unit, which then makes us, after we have talked to one device once, we know its IP address and Modbus address. So the next time it becomes a Modbus packet, we send it to one dedicated device to avoid flooding the network every time and talk to all the nodes all the time for every Modbus packet. You're considering a library for any coded television studio code as for Arduino? Well, I'm not sure what you mean, but our SDK is we do have support for Visual Studio Code, actually. So that means if you open the SDK from Visual Studio Code, you can build and compile everything directly from Visual Studio, and we also have like what's called auto finish of variables and stuff like that based on the API that we have. So we do have integration with our SDK for Visual Studio Code. You can also, there's a video out on that as well, how to use that, because we do know that the developers like that tool. Let's see. I think I covered most of the questions now. If David had some more information about what he is asking about OPC UA, I can maybe comment that a bit more. But if not, then I will like to thank you for attending this webinar. I hope I was able to share some insight in how wireless solution can be integrated with the automation system, how we offer that with our RIIM solution today, what's available of example code for that, and then I just wish you luck developing your wireless solutions together with your automation system. If there's any more question, you can of course contact our support later for more details and that stuff. And the recorded video of this webinar will be posted live, posted afterwards on our YouTube channel. So posted on our YouTube channel, so you can see it, or your colleagues can see it later. Okay, then thank you and have a good day.